This is the homework video for Math 8, Math 7 Accelerated, page 205. And I think, I just wrote on the page. Okay, and we were looking at 1 through 7. And I think a lot of classes got 1 through 4. And if you got the rest of them, that's awesome too. So let's see. Let's go ahead and start with this first one. What this is saying is when x is 12, what it's asking you to do is to replace this x here with the 12 that's here. And if I was to rewrite it, it would be y is equal to 3 times 12 plus 10. Well, that looks like that's going to be 3 times 12 is 36, plus another 10 is 46. And that's how you would do problem number 1. Problem number 2 is kind of similar, except notice this time it's saying I'm going to give you the y value and solve for the x. So this time you have to say y 10 is equal to a negative 4x plus 42. And make your math wall here. Subtract 42 from both sides. Oh my goodness, we get negative 32 is equal to a negative 4x divided by negative 4 divided by negative 4, and I think our answer has to be positive 8. We continue here and we look through here. Man, we're going to get some decimals here, so I should probably open up a calculator. And let's see. So I'm going to open up Desmos graphing calculator. See what we get here. Alright, Desmos graphing calculator. Actually, I'm going to go back one. I don't need graphing calculator. I just need scientific calculators. Really what I need. So we're going to have this open for us, and we'll come back to it as we need to. Alright, so it looks like this time they give us the variable p, and they tell us what it's equal to. So I'll work over here. So 37.6 is equal to 24 plus 0.8n. Make my math wall, subtract 24 from both sides, and I'm left with, well, that looks like that's going to be, what was that, 13.6, and that's 0.8n. Divide by 0.8 on both sides, so where my calculator is going to come in. 13.6 divided by 0.8. Let's see, right there. 13.6 divided by 0.8. Looks like the answer is 17. Alright, cool. So we'll jump back over here. We know the answer has to be 17. N is equal to 17. And we're done with that one. And then finally, this guy, it looks like they gave us D this time. So D is equal to 15. So we'll go over here. So T, capital T variable, is equal to 40 minus 1.6 times 15. So let's see, we need 40 minus 1.6 times 15. So let's jump over our handy dandy calculator and clear this out. 40 minus, let's see, I've already forgotten what the problem was. 1.6 times 15. 1.6 times 15. So our total answer, they do the multiplication first and then subtract that from 40, and we'll get 16 as our final answer. And I'll go ahead and write that in. Oops, sorry, I keep kind of writing on the board here. Let's erase that. And moving on, so question 5, and this is really where a lot of the questions started to come up. It says what value, and I've read this already, so I'm going to kind of jump to the question here. So what value of x would represent 2020? Well, we need to go back to, it says where x represents the number of years since 1980. Well, is 2020, well, that seems like that's 40 years after this, so x has to be equal to 40. It's 40 years since 1980. And then we're going to use the equation here, and we're going to say, well, we want to plug in for x, we're going to use the 40. So we'll write our equation here, y is equal to 29 minus 0.2 times 40. So 29 minus 0.2 times 40. I'll type it in, and let's get rid of that. 29 minus 0.2 times 40. And it looks like it's 21 is the answer. I think I did that right. 29 minus 0.2 times 40. Jump back over here. Oh gosh, I already forgot the answer. I really should have a second window open here. Alright, so that's going to be 21 is the answer we're going to write down. And that is 21 for this is part B, is what I just did. In what year will the student population reach 18 students per class? Well, I go back here and the y variable is students per class. So now it's telling me to put 18 in for the y variable. So let's go ahead and do that. So we'll say 18 is equal to 29 minus 0.2x. Make our math wall, minus 29, and I think this becomes negative 11, and this is still negative 0.2x, divide by negative 0.2, divide by negative 0.2, and for some reason I think this is going to be 55. Let's see. So negative 11 divided by negative 0.2. Let's go over our handy dandy calculator. Get this guy out of here. Negative 11 divided by 0.2. And I think it's negative 0.2. And that's positive 55. Okay, so we're pretty close to being right. Or actually, we're exactly right. So that says that in 50, and then let's interpret this for a second. So x is the number of years since 1980. So in 55 years, we're going to get 18 kids per class. All right. So let's see, does this equation accurately predict the class size of the school in the year 2050? I think if you plug in, so 2050, that's going to be when x is 70. Plug in 70 for x and see what happens. So just like in this problem where we hit the 40, we put in the 70, and I think you end up getting 15 for y. And I mean, you could say yes, it does model it. We're going to keep getting smaller and smaller classes, or you could say no, classes are going to get bigger and bigger. And really, that one, you can answer it either way, but this is how you're going to do it. You're going to say x is equal to 70. So we look at question 6. Mike and Aurora organize a whitewater rafting trip with their friends. The more people they can get to go on the trip, the less it costs per person. And let's see. So they've got this C is the cost per person. That seems important. And P represents the number of people. Okay? So we got the cost and number of people. If 15 people go on the rafting trip, how much will it cost per person? Well, they're telling you to take, in the letter P, write 15. So for this problem, so I'll put question number 6 here, we're going to take C is equal to 35 minus 0.75 times 15. And what we'll get is, we'll say C is equal to, and it's going to say 35 minus 0.75 times 15. Let's see. Let's see what happens. So let's go over to our calculator. Typed it in. It's 2375. All right, so 2375 is what we expect it to cost. All right, how many people need to go to get the price down to 20 bucks per person? Well, now they're telling you the C value. So this, we just found this, if it's 15 people to go, it's going to cost 23. This time they're telling you what the cost is. So this time they want you to put 20 in for C and figure out what the variable P will be. So we'll make our math wall, we'll subtract 35, and we end up with a negative 15 is equal to a negative 0.75p, and we'll divide by negative 0.75 and divide by a negative 7.5 or 0.75. So in my calculator, I'm taking 15 and divided by 0.75. 15 divided by 0.75. I dropped the negative sign because I know the answer is going to be positive, and it looks like 20 people need to go. So in this case, we need P to equal 20, and then it will be the same price. If 50 people go on the rafting trip, let's see what happens here. 50 people go on the rafting trip, how much will it cost? Is it reasonable to use this for 50 people? Well, let's see. So 50p, that's the variable p, so let's go ahead and plug this in. So C is equal to 35 minus 0.75 times 50. Well, let's try it. Let's just plug it in. So 35 minus 0.75 times the 50 people. So negative $2.50. Well, this one, no, you can't charge negative. You're not going to pay. What this is saying is this is saying that everyone will get paid $2.75 to go on the trip. No way, that's crazy. All right, so it has to be no, and you can't have negative costs for a trip. All right, the last thing, it looks like this is men's 100-yard dash. Okay, so we got the scatter plot. They've made the Q lines in here. It looks like this is going to be a line that matters, a point that matters. This is the other Q point that matters. Describe the correlation. Well, it looks like it's negative because it's going down to the right. Negative. And then name the two Q points that follow the direction of the data. It's this guy and it's this guy. I'll let you figure out the points. So it's 1940-ish and 10.4 it looks like. The equation is approximately this. Use the equation to predict the winning 100-meter dash in 2052. Well, this time I think you actually are going to plug in this 2052 right here for x, because the x's, it looks like they are going by years. So plug in that 2052. Use the equation to predict the winning time. You use the equation to predict when the winning time will decrease to 8 seconds. Is this reasonable? Well, here's where I'm going to say it might not be reasonable no matter what. Then we probably will get to a point where you can't improve the time anymore. But let's see. So they want 8 seconds. So this guy right now that is going to be the y variable. So the winning time is this variable right here. So we're going to put in 8 for y. So 8 equals negative 0.0083x plus 26.53. And we'll make our math wall. And I'm going to be honest, I'm going to run into trouble trying to do all this on the calculator here because I'm not going to remember all these decimals. But this is the process. And you're going to end up with some big negative number here and negative 0.0083x. And you'll divide both sides by this decimal. And I would imagine that the answer is sometime in the distant future, and you can either say, yes, that seems reasonable because we're going to start becoming robots and we're going to get super, super quick. Or you can say, no, there's probably a limit to how fast we can get. I'll leave that up to you. All right, I hope this helped. I kind of went a little bit longer than I was hoping to, but I hope this helped to see kind of a walkthrough of most of the problems. Email any questions you have, and have a wonderful night.